Hey guys, this is the virtual notebook for greatest common factor and least common multiple, which is our new material that we're going to start learning this week. We will be having a test over this next Wednesday. You can open this notebook up from Schoology. If you go into your math course, it will be under upcoming, and this is the title. It's the 6.NS.4-GCF LCM virtual notebook. This is the title slide on the notebook. If you go to the second slide, this is a linked table of contents that will take you to the different sections of the notebook. This notebook just has the material in it that will be on your test for next week, which would also include the vocabulary that we went over yesterday. So we're going to get started today with greatest common factor, and this is a notes page that explains what greatest common factor is and a couple different ways that you can find the greatest common factor. Now, these aren't the only two ways that you can find greatest common factor, and you may have your own way that you've learned in the past that works for you, but I'm just going to show you a couple of different ways here that you can find the GCF. So the greatest common factor is the largest factor that two or more numbers have in common. And factors are numbers that you multiply together to get another number. So for example, if we had 2 times 3 equals 6, these two numbers are the factors. And most numbers have factors. In fact, all numbers have factors. Sometimes it's only one in that number, but all numbers have factors. Now, if you have a number like 2 or 3 or 5 or 7, they only have factors of 1 and themselves. And we call those prime numbers, okay? And then the other kind of numbers like 6 are composite numbers because they have more factors than 1 in themselves. They have other numbers as factors. So what we're dealing with here are factors of numbers, what numbers you multiply together to make other numbers. For finding the greatest common factor, one way to do it is to make a factor list. And the first thing that you should do, no matter what you're going to do, is you should always check and see if the smaller number is a factor of the larger number, because if it is, okay, that has to be your GCF. Your GCF can never be greater than your smallest number because this is the greatest number that divides into both numbers evenly, and we're only going to be dividing in evenly numbers that are the size of the smaller number or smaller than that. Now, if that doesn't work out for you, there are two methods you can try. The first one is to list your factors, and I'm going to show you that you really only need to list the factors of the smallest number to find the GCF. The other method is called birthday cake, and it's a way of using the distributive property or factoring out, which just means dividing common factors until you get to the greatest common factor. So to do the birthday cake method, you're going to list your factors side by side, and then you're going to factor out any common factor through division. Factoring is dividing. So you're looking for any common factor. It doesn't have to be the greatest common factor. You will keep doing that until the only factor that the two numbers share is 1. And when that happens, you will have everything you need to find the GCF. You will then just multiply all of the common factors, and that will be your GCF. Now, I'm going to show you how to do both of these methods, but these are the step-by-step instructions that you can refer back to. If you're not done drying and dropping, go ahead and pause the video now, and you can continue that process. All right, I'm going to go through some examples now of finding greatest common factor between two numbers using factor lists and using the birthday cake method. If you're a person that has trouble finding all the factors, I would recommend using birthday cake because it's foolproof. You don't have to make sure that you list every single factor. You only have to find one common factor. So let's start with 12 and 26. And the first thing I want to do always, is I want to see if my smaller number is a factor of my larger number. And if you don't know if 12 goes into 26 evenly, you should just skip count by 12. So we would go 12, 24, and I know 24 is only 2 away from 26, so another 12 is not going to fit in there. So 12 is not a factor of 26. So to make the factor list, you probably learned a way where you list out the factors of 12 and 26 and then look for a match. But what I'm going to tell you is you don't even need to look for factors of 26 because the GCF cannot be bigger than your smallest number. So you really only need the factors of your smallest number to know what your GCF is. So these are all the factors of 12, 1, 2, 3, 4, 6, and 12. And I'm just going to go from the largest factor to the smallest until I find the one that 12 and 26 have in common. So I already determined that 12 won't work. So now I'm going to try 6. Does 6 go into 26 evenly? And it does not, because 6 times 4 is 24 and 6 times 5 is 30. So that is all around 26. It's not 26. Does 4 go into 26 evenly? It does not, because 4 times 6 would be too small and 4 times 7 would be too big. Does 3 go into 26 evenly? 3 times 7, 3 times 8, 3 times 9, not going to work. Does 2 go into 12 and 26 evenly? And your divisibility rule should tell you that it does, because 12 and 26 are both even numbers. So 2 is the greatest number, the biggest number out of all the factors of 12 that is common or will divide into both 12 and 26 evenly. So the greatest common factor of 12 and 26 is 2. That is how you do the factor list, okay? So let's go ahead, and we'll come back to birthday cake in just a minute. Let's go ahead and work through this top row here. So for the next example, we've got 15 and 45. So again, we want to look and see, does 15 go into 45 evenly? And if you don't know that off the top of your head, you can just skip count. 15 plus 15, 30 plus 15 is 45. If your smaller number divides into your larger number evenly, it is your GCF. You don't need to go any further than that. Okay? 21 and 49. Let's see here. We got 21 and 21. It's 42. Plus 21 is 63. So that is not going to work. So we need to do our factor list for 21 only, because our greatest common factor cannot be bigger than 21. So the factors of 21 are 1 and 21, 3 and 7, 4 doesn't go in evenly, 5 doesn't go in evenly, 6 doesn't go in evenly, 7 does, but it's already on my list, so that means I have no more common factors. So now I just want to start here and work my way back to find the greatest common factor. So 21 does not go into 49 evenly. Does 7 go into 49 evenly? Yes, it does. 7 times 7 is 49. So this is the largest number that will common to both, divide into both evenly. It is a factor of both. 7 times 3 is 21. 7 times 7 is 49. So it is the greatest common factor. All right. And last here, we got 18 and 54. So we want to know, does 18 go into 54 evenly? So I'm going to just start skip counting to see. 8 and 8 is 16. So that's 36. 6 and 8 is 14. And it does. 18 goes into 54 evenly. So the greatest common factor here is 18. Now, some of you might have looked at 18 and 54 and thought that the greatest common factor was maybe 9, because 9 goes into 18 and 54 evenly, or 6, because 6 goes into 18 and 54 evenly, or maybe 3, okay? If that's the case, you probably would be interested in doing the birthday cake method, because the thing that's great about the birthday cake method is you don't have to have the greatest common factor. You just have to have any common factor. So I'm going to start at this end and work my way back on birthday cake. It's called birthday cake because the end result looks like a cake, okay? But really it's just dividing. So first, you're going to take your two numbers and you're going to write them side by side. Then you're going to start dividing, kind of like we did up here. That's how you find factors, is dividing, but you're just going to do one factor pair, and it can be any factor that you know. So let's say you're looking at 18 and 54 and your brain is tired and you can't think of anything that goes into 18 and 54 except for 2. You know 2 goes in because they're both even. So we're going to put a 2 out here, and you can see I've drawn a division symbol. I'm going to divide 18 and 54 by 2. That is factoring it out. I'm going to make factor pairs just like we did here in the list, okay? So I'm just going to make the one pair, though. I'm going to make the pair of 2, and whatever goes into 18 evenly 2 times, which is 9. So 2 times 9 is 18. 2 and 9 are my 2 factors. 2 is the one I'm factoring out right now. So how many times does 2 go into 54 evenly? Well, it's going to go in 2 times with 1 left over, and then 2 is going to go into 14 evenly 7 times. All right. Now, at this point, you have to ask yourself, do 9 and 27 share a common factor? Is there another number that I can factor out of both 9 and 27? And there is, because 3 goes into 9 and 27 evenly. So 3 goes into 9 3 times. 3 goes into 27 9 times. So I have another layer to my cake. Next, is there anything that goes into 3 and 9 evenly? There is 3. So 3 into 3 1 time, 3 into 9 3 times. Is there a number besides 1 that divides into 1 and 3 evenly? There is not. So that means our cake is complete. We can put a candle on the top. Now, along this side of the cake, you have a decoration. These are all the numbers that you have factored out. Now, they're not the greatest common factor. They're just common factors. So we need to combine them to get the greatest common factor, and we're going to combine them through multiplication, because remember, greatest common factor is all about multiplication and division. What do you multiply to get a number, or what divides into a number evenly? So we're going to do 2 times 3 times 3. So I'm just going to write that to the side here. 2 times 3 times 3. 2 times 3 is 6. And 6 times 3 is 18. So using birthday cake method, we find that the GCF is 18, just like we did on top. Okay? Now, I'm going to do birthday cake method one more time, and I'm going to do it here with 15 and 45. So I'm going to write 15 and 45 side by side. Okay? I want to divide out a common factor, so I'm going to put a division symbol over 15 and 45. I know because these both end in 5 that 5 is a factor, because remember, with birthday cake, you can use any common factor. I'm factoring it out, which means divide. So 15 divided by 5 is 3, and 45 divided by 5 is 9. I'm going to ask myself if 3 and 9 share a common factor. They do. 3, so I'm going to divide that out. There's 1, 3, and 3. I'm making a factor pair right here. There's 3 3s and 9. And 1 and 3 do not share a factor other than 1. So I'm ready to put a candle on my cake. And these numbers here, multiplied together, will give me my GCF of 15. Okay? Now, if I were you, what I'd do right here is pause this video, and I would try birthday cake with 12 and 26, because I'm about to do the birthday cake for 12 and 26. So I'd pause it here and try it on my own, and then you can start the video and see if you get it right. So I'm going to put 12 and 26 side by side. They're both even, so I'm going to use 2 to divide. So 2 and 6 is the factor pair for 12. 2 and 13 is the factor pair for 26. 6 and 13 do not share a common factor. So I'm done with my cake. My GCF is 2. All right, pause here so that you can try 21 and 49 using birthday cake. Got 21 and 49. Looking for something that will divide into both evenly. It's going to be 7 for me. 7 into 21 goes 3 times. 7 into 49 goes 7 times. 3 and 7 do not share a common factor other than 1. So I'm going to put my candle on my cake, and I've got my GCF of 7 here. So these are the two methods that you can use to find greatest common factor for two numbers. You can pause here if you need to write any of this down. I'm going to move to the next slide. Okay, so this is word problems with greatest common factor. And remember from what we talked about with word problems last week, we want to look at the situation and not just keywords. Okay, so the situation for greatest common factor problems could be one of several things. So I'm going to go here because I've got a drag and drop on here. The problem could just come right out and ask you to find the greatest common factor. So that could happen. Look for that. If you see that, it's a greatest common factor problem. The problem could be asking you to put things in groups together. And this is going to be different than a straight division problem because it's going to ask you to take several different amounts and put them into equal groups. And I'll explain that more in just a minute. Last, you also could look for keywords, but you need to have keywords in addition to one of these other things. And the keywords would most likely be greatest, most, or maximum. Now, these are also keywords for inequalities problems. So you cannot just see greatest, most, or maximum and assume it's greatest common factor because it could be inequality. And when we get to inequalities, I'll bring this to your attention again. But if you're looking for several things that you're putting into equal groups together, that's your cue that you've got a greatest common factor problem. So I'm going to read this one to you now, and I'm going to work through how you can figure out that this is the greatest common factor problem. It says Charlie is making cookies. He has 100 chocolate chips and 125 pecans. So he's got two different amounts of two different items, chocolate chips and pecans. If each cookie must have the same number of chocolate chips and pecans, what is the maximum number of cookies that Charlie can make? So what's happening here is we're taking the chocolate chips and the pecans and we're putting them in groups in a cookie together. And we have to take two different amounts, but divide them so that there's an equal amount of each in every group. That is the greatest common factor problem. We have to figure out how many groups we can make out of 100 chocolate chips and 125 pecans, where there will be an equal number of chocolate chips and pecans in each cookie. So that means that we're going to take 100 and 125, and we are going to do the steps for greatest common factor. So you should pause the video here and either use factor list or birthday cake to find the greatest common factor of 100 and 125. Then turn your video back on and check your answer. All right, I'm going to start with birthday cake because I know 100 has a lot of factors and I don't want to list all those out. So I'm going to start with birthday cake because I only need one factor to use that method. So I'm going to divide 100 and 125 by any factor that they have in common. And I know because 100 ends in 0 and 125 ends in 5, that a 5 will divide into both evenly. So now I'm going to make my factor pairs for each of these numbers with the factor of 5. So 5 times 20 is 100. And 5 times 25 is 125. So now I look at 20 and 25 because I don't have 100 and 125 anymore. I factored it out. I'm left with 20 and 25 now. Do they have a common factor? And they do. Got another 0 and another 5 here, so it's going to be 5. So I'm going to make my factor pairs that go into 20 and 25 with 5. That's their common factor. So 5 times 4 is 20, and 5 times 5 is 25. Now, 4 and 5 do not share a common factor other than 1, so I'm ready to put my candle on my cake and multiply my two factors that I factored out by each other, 5 times 5, and that gives me 25 as my GCF. Now, if you did this another way and you got 25, that is fine. I only really want you to be able to figure out greatest common factors. It's not necessarily about the method. All right. To wrap up this lesson, there is an exit ticket of questions, 4 questions that you need to answer so that you can let me know if you are understanding these concepts or not. So if you have opened this slideshow up, I have access to it because when it made you a copy, it put a copy in my Google Drive as well. So as you work through these problems, go ahead and just type your answers in. So you can literally just type in here GCF equals or GCF colon, and then type the numbers in, put your answer in, and you don't submit it because I'll be able to see it through my Google Drive. So I need you to do these 4 problems to just check for understanding. So I'll know who needs more greatest common factor help and who has got it. If you have any questions, just shoot me a Schoology message. Thank you so much, and I will see you guys later. Bye-bye.